Hey everyone, and welcome to The Explainer. Today, we are taking a totally mind-bending journey into the absolute bleeding edge of human connection. We're talking about a future that, honestly, sounds like pure science fiction, but it's actually being built right now, layer by layer. We are going to break down this fascinating technological roadmap known as high-level telepresence, and specifically the 10 layers stack required to actually make it a reality. So get ready, because the way we think about physical distance, and literally our own bodies, is about to fundamentally change.
Okay, let's dive right into this. I want you to picture a scenario for a second. You are physically sitting in a chair in Tokyo, but you're looking around a room in New York. You can actually hear the traffic outside that New York window. You reach out, you feel the cold metal of a desk in that room, and when you push a coffee mug across it, a robotic arm in New York does the exact same thing in real time. So the ultimate thought experiment becomes, are you in Tokyo or are you in New York?
To answer that, we've really got to define what we mean by high-level telepresence. This is not just throwing on a headset for a standard VR meeting. It's the ability to feel, see, hear, touch, and physically act in a remote environment, using AI and robotics. It's like you're existing in that space as if your body were actually there. But here's the catch, and the source material makes a great point here. To achieve this seamless illusion, we need 10 distinct layers of technology, advancing all at the exact same time. If even one of those layers lags behind, the whole illusion just shatters.
Section 1. Beyond simple VR meetings, evolving from screens to reality.
So, the very first crucial layer is vision. Right now, current VR relies heavily on 360-degree video on flat visual panels. And sure, it's immersive, but your eyes definitely still know they're looking at a flat screen. Future telepresence, though, relies on something truly wild: light field displays. Instead of just showing you a 2D picture, this tech literally recreates the physical light rays bouncing off objects. This gives your eyes natural depth, focus, and parallax. Basically, your eyes function exactly as they would if you were physically standing in that remote room.
Section 2. Recreating the human senses, vision, audio, and haptics.
Now, what's really interesting here is that vision is just the start. Let's talk about audio. We aren't just talking about your standard stereo sound. We absolutely need spatial audio. If someone is approaching your remote robot from the back left, you need to hear their footsteps coming precisely from your back left. The tech has to account for the exact distance, how the sound bounces off the specific walls in that room, and even if a piece of furniture is blocking the sound. It has to perfectly mimic real-world acoustics.
And then, oh boy, we get to the hardest part. Haptics. The science of touch takes the difficulty level through the roof. It's not just a basic little vibration in a controller anymore. Future haptic gloves will need to transmit force feedback, pressure, the exact temperature of an object, its texture, and even shear force, which is the friction of sliding your finger across a surface. You will literally be able to feel if a mug in New York has hot coffee or ice water in it, straight from your living room in Tokyo. It's absolutely crucial because true presence requires the nuance of touch, whether you're operating delicate surgical tools across the globe or just feeling the warmth of a handshake.
Section 3. The digital nervous system. The infrastructure powering presence. So the crucial point for making all of this work is latency. We need an end-to-end delay of just 1 to 10 milliseconds. Think about the crazy pathway here. The camera sees something, it blasts through the network, into the AI, down to the robot, and all the way back to you. If that delay hits even 100 or 200 milliseconds, your brain experiences severe cognitive dissonance. It basically says, hold on, this isn't my body, and you end up feeling sick or completely disconnected. To keep the illusion alive, the reaction time has to be virtually instantaneous.
To achieve that kind of impossible speed, we need a massive, real-time computing and networking pipeline. We're talking about combining fiber optics with 5G and 6G infrastructure. We need edge computing to process video, audio, and physics simulations locally and instantly. And the data compression alone? It requires dedicated AI just to shrink the file sizes down enough to blast them across the globe without a single hiccup. We are essentially rebuilding the internet from the ground up, just so you don't accidentally knock over a coffee cup on the other side of the world.
Section 4. AI and remote bodies. Embodied telepresence in action.
First things first, your remote body needs to actually understand where it is. This is spatial computing. Using things like LiDAR, depth cameras, and SLAM, which stands for simultaneous localization and mapping, the remote robot can instantly comprehend its environment. It knows exactly where a desk is. It knows a person is standing to its right. It knows there's a staircase exactly 10 meters ahead. It reconstructs the 3D space and recognizes objects flawlessly so that you can navigate safely.
But what about moving that robotic body? And this brilliantly illustrates how AI becomes the absolute biggest game changer in this entire stack. Remember that insanely strict 1 to 10 millisecond latency limit? Well, sometimes physics and geography mean you just can't beat the clock. So we cheat. Step 1, you intend to move your hand forward to grab an object. Step 2, the AI observes your motion and predicts your intention before the signal even fully arrives. Step 3, the AI commands the robot to start moving and grabbing the object ahead of time. By anticipating your actions, the AI completely masks the network delay from your conscious mind. It's brilliant.
This flows perfectly into the whole digital twin loop. Imagine you're in Tokyo, supervising a factory in New York. The sensors in the real world capture the factory environment. The AI then instantly reconstructs this into a 3D digital twin, a perfect real-time virtual simulation. You step into this virtual space, and as you operate your controls, the AI simulates the physics, predicts any dangers, and then translates your actions back to the physical robot in the real world. The real and virtual worlds just become perfectly synchronized in this continuous, flowing loop.
Section 5. The ultimate distributed body, the final convergence. To achieve this ultimate state, we honestly have to get rid of clunky VR controllers and motion capture gloves altogether. The future of this interface relies on neural interfaces. This means we bypass physical movement entirely. If you want to move the robot's right hand, your brain sends the signal. A computer reads that neural intent, passes it through the AI for prediction, and directly moves the robot. The pathway becomes beautifully simple: brain to AI to robot. When you combine all of these advanced layers, you achieve what the source text calls the distributed body. And honestly, just pause and think about the sheer magnitude of this concept for a second. Your biological body is resting in Tokyo, but your vision is mapped to the eyes of a robot in New York. Your hearing is mapped to the acoustics of that New York room. Your sense of touch, the movement of your limbs, your spatial awareness, all of it is being outsourced to a robotic proxy and processed by an AI halfway across the planet. Your physical and sensory functions are no longer contained in one single biological shell. They are literally scattered across a global network. The author of our source material hits the nail on the head, saying, "I think the final form is the distribution of the body." When we look at the next 100 years of telepresence, things like optical communications, AI semiconductors, advanced robotics, haptics, and neural interfaces aren't just going to exist as separate, isolated tools. They are going to seamlessly converge into one massive, interconnected technological system that basically acts as an extension of our own biology. Which leaves us with a truly mind-bending final question to ponder. We've built the 10-layer stack. The latency is 0. The haptics are perfect. The neural link is completely flawless. If every single one of your senses and every physical action you take is occurring in New York, but the biological brain processing it all is just sitting in a chair in Tokyo, where are you really? It completely blurs the boundary of reality and human existence. It is such a fascinating future to look forward to, and one we are building layer by layer right now. Thanks so much for joining me on this explainer, and I'll catch you on the next one.